Okay, let's get started. So now we're going to start talking about the elements. And elements are considered the fundamental or elementary substances. So if you notice a commonality here, elements, elementary. Okay, and these are our basic building blocks. We can't get any smaller than our elements via chemical means. So we can't like run a reaction and break down an element. That's the smallest that we can go, the simplest, most fundamental substance. Now, the smallest particle of an element is called an atom. Okay. And again, can you break down an atom? Not necessarily via chemical means and have it change its properties of an element. Okay. Now, when we talk about that, the natural states, so when we talk about the states of our elements, we can find them to exist as solids. A lot of our metals are solids, right? And we have liquids. Bromine is actually a liquid. And then we have gases, helium, oxygen, nitrogen, okay, xenon, hydrogen. Those are all in the gas form. Okay, so those are our typical physical states. Now, when we also look at our elements, many of the elements are too reactive to remain as elements. Okay, so when we find them in nature, they're going to be in compounds. Okay, some of them, like if we look at copper, we have copper veins. So we'll have what we call like noble gases. They're not reactive. That's why neon and helium are just single atoms that float around in our atmosphere as gases. And then basically we have what we call noble metals like gold and silver and copper. And those tend to be not that reactive. Okay. However, sodium is highly reactive and will combine immediately. Okay. So we don't see sodium normally as just the metal. It easily combines with the oxygen in our atmosphere to form sodium hydroxide. Okay, so we have that aspect as well, but we can get the simplest fundamental substance. Okay, and those are elements. And if you look at our current periodic table, there are about 118 of them. Okay, a significant portion, if you look near the bottom of the periodic table, significant portion are going to be man-made. So it's made for maybe a nanosecond and we can see it, and then it basically decomposes. All right. Now, when we look at elements, we don't always just write them down by their name. Okay. What we do is we have symbols. Okay. And so the symbols are 1 or 2-letter symbols. And they typically are abbreviations or close to that based on their Greek or Latin or German names. And then some of them, the newer ones that have been man-made, are named after places and people. All right. But when we look at the symbol, okay, then for the, if it's only a 1-letter symbol, it's always capitalized. Okay, and we have 2-letter symbols. Then the first letter is always capital, and the second letter is always lowercase. Now, this is really important to follow. So the spelling aspects is really crucial because you can have, if you write your name in lowercase or everything's in uppercase or capitals, then the problem is that we won't know what you're talking about. So if you see something like CU versus CU, this tells me I have a carbon atom and a uranium atom. Okay, this tells me I have copper. So they can mean completely separate things. I have a compound here. This is a compound. They have two elements, and this is an element. So it's really important that you keep track of how we write our symbols. Okay. Now, what about some unusual symbol? So for carbon, we have a C. That's not surprising. For copper, we have a C, but basically is not CO because that is taken. Okay, so it's a two-letter symbol. So how do we know what they are? Okay, and that you're going to have to memorize. But just be aware, even though most symbols all right, start with the letters in the name, or they have the letters in the name, let's say. Some of those symbols, okay, are from their Latin names. From. Oh, I can't spell it. So you're going to have to make sure you know your symbols. In other words, know your symbols, know your names. It's like learning a new language, right? So you need to know your nomenclature. All right, so let's give you some examples. Okay, barium, the element barium, has an abbreviation of Ba. Well, first two letters, that's pretty common. Since carbon is C, then chlorine can't just be C because that's carbon. So they take Cl, okay, for chlorine. All right, iodine is I. All right, so in cobalt can't just be C because that's carbon. So it's the first two letters, C-O. And notice how the second letter is lowercase. Okay, now what about these others that you need to know? So some of the others can be very common elements like potassium. And potassium's abbreviation is K, all right? And that's for kalium. So what happened to the P? So just, you know, phosphorus is the element whose symbol is P. So know the difference, because a lot of times I've seen P used for potassium, but it's not. It's K. All right. So know your table 3.4. Okay. And I'll go through and show you some more. So let's just show you a table. It doesn't have all of the elements in there. It has a lot of the elements in there that are common that you'll see quite often. And then we'll move on to the table. So let's go ahead and take a look at that table. All right, so here, okay, so here what do we have? Aluminum Al, that's common and not surprising. But look at antimony, it's Sb, right? Argon Ar, that's pretty common. Arsenic As, okay. Barium Ba, beryllium, these are not surprising. Bismuth, boron, bromine, okay. But when we get down to here, gold, Au, all right, for auric, all right. Iron, Fe, that's for ferrum. So when you go through this, this is plumbum, okay. So you see lead is Pb, there's not an L in there, okay. So just be aware of where you get unique symbols, mercury, Hg, okay, to your name. So what you need to do is become very familiar with your names and symbols. And I suggest just like every night, memorize another 2-3 elements and their symbols before you go to bed. Makes a really good bedtime reading. Okay. Now, how do we also put it? We don't often see this as tables. We can get tables. That works out beautifully. But what happens if we do it this way? The periodic table, not a chart where you have everything listed, but a periodic table, because the periodic table actually gives us a lot of information in the way it's established. And so let's just go through. And that's not what I wanted to do. I wanted to draw on this. Draw. Okay, there we go. So let's take a look at the box. All right. So each element has its own box. And in the box, you're always going to see your symbol. You can't see through that. Okay, you'll always see the symbol in your box. You might not always see the name. That's why you need to know your names and symbols. But you'll always see your symbol above it to the left or right above it in the center or even to the right. You'll see a whole number, an integer. And that whole number, starting with 1, this is unique per element. This is called your atomic number. Okay. And we sometimes abbreviate it with a Z. And this is unique per element. So if I say, oh, I have an atomic number of 27, you know I'm talking about cobalt. If I say, oh, what's the atomic number for phosphorus? You go to phosphorus and you see, oh, the upper left is 15. So I know my atomic number is 15. Okay, so they are unique for each other. Element and atomic number. At the bottom here, atomic mass, this is an average mass. So that's why it's not a whole number. Okay, and we can go through those calculations at a later chapter. All right, but in this periodic table, you'll also have the name. So be sure to practice memorizing your names and your elements. Okay, so what we have is we have a series of boxes, and how are they laid out? Okay, why is it called a periodic table? What is the common theme that we find in here? So each of the rows are called periods. Okay, so I'm going to erase this part. So each row is called a period. So this is row 1 or period 1, 2, 3, 4, 5, 6, 7. These two, okay, actually see these boxes here? These two get inserted into these boxes. And the reason that they're put down lower down is because basically now we can fit this table into a single page. It makes it a little easier to follow. Okay. What else? Well, now that we have all our periods established, what else do we need to talk about? Well, also what we need to talk about are our families. So the column, okay, is a group or a family. Okay, and you can see there are different ways that we write it. 1A, Roman numerals, and then just the numbers 1 through 18. But we're going to focus more on using the A's and the B's. Okay, so when we go through the periodic table, the A's and the B's, so you're going to have 1A, and notice it goes from 1A, 2A, 3A to 8A. These are called main group elements or representative elements. Okay, typically we call them main group, but if you hear us talk about representative elements, we're talking about those elements that are in the columns with an A after it. What about the other ones here inserted down below? So we have 3B and then it resets to start back. 1B, 2B. This is actually like an 8B, all 3 columns there. So all of these other ones with the B's, okay, even down here, since they're inserted in here, these are called transition elements. Okay, so we have 2 classes, main group elements with the A's, and then the transition elements starting down here with the B's. We have periods. Each column is a group or a family. What else does the periodic table tell us? So let's go through. We have metals, non-metals, and metalloids, are also known as semi-metals. Okay, so if we look at these, let me just use this marker here. All right, so except for hydrogen, which is a non-metal, we could draw it over here. There's a step mark right here. See how? Okay. I don't like that. Let me just change the color and erase this. Okay. Let's do that. All right. So you have like basically the staircase right there. Okay. And these don't really. And when we look at it, then what we're seeing is that our metalloids touch the staircase. So in the staircase, everything to the left of that purple staircase are going to be metals. Everything to the right, starting with carbon, nitrogen, oxygen, are nonmetals. Okay. And then touching the staircase, then we get our metalloids. So boron can be considered a metalloid, silicon, germanium, arsenic, okay, antimony, tellurium, polonium, okay, even astatine. These don't exist long enough. So what's the difference between the two? So what we're going to do is we're going to go through the differences between metals, nonmetals, and metalloids. So let's continue to focus on our periodic table first before we get to more specifics. So our periodic table tells us which ones are metals. So lithium is a metal, magnesium is a metal. So like I say, except for hydrogen, which is a non-metal, and always shown on the left of that staircase, starting with period 2, everything left of that staircase is going to be metals. Everything to the right, non-metals. And touching, you get your metalloids. Then I have 1A, 2A, 3A to 8A. Those are my main group elements. Everything here, including these guys, okay, my rare earths, these are considered transition elements. So what are these families? Why do we put them in a family? It turns out the reason we put these elements into the periodic table and a family is a family has similar reactive behavior. So families undergo the same reactivities. Okay, there are some nuances, but basically, if I run a reaction with chlorine, then you know that reaction should work with bromine, should work with iodine. If I run a reaction with sodium, then you know potassium is going to behave the same way. Okay, so families tell you that they have the same type of reactivities, chemical reactivities. Okay, so let's go through and name these families. So there are some that are often encountered and common enough that we have names for them. So starting with lithium, these 1A metals are also known as alkali metals. Alkali means base. So why are they called alkali metals? It so happens when you take something like, let's say, lithium, and I react it with water, you form a base, you form a hydroxide. And it bubbles because you form hydrogen gas, okay? If I say, well, what about potassium? You know what? You just replace the lithium with potassium. It does exactly the same thing. And I needed 2 here. Okay, so basically they have the same type of reaction. They both react the same way with water. And because they form hydroxide, which is a base, they're called alkali metals. Okay, they're metals and they form bases in their reactions. What about 2A? Well, 2A, they are alkaline. So again, they form a base, earth metals. And why are they called earth metals? Because basically we find them in a lot of minerals when we dig through the earth. So alkaline earth metals for 2A. Then we're going to skip over here. 7A, these are called halogens. Okay, so like halogen lamps. They're halogens. So halogen lamps, most likely, I have to look it up, see which halogen's in there, but we'll have halogens in there. And these guys are very unreactive. These are noble gases. All of the elements in 8A are all gases, and they're called noble gases because they're very unreactive. Okay, they don't really combine with anything. Okay, so now you know your periodic table. Each box will tell you what the atomic number is, and we'll go through, but that tells you the number of protons per element. But the atomic number and the symbol and the element name, those are unique to each other. And then we can get our average atomic mass. In the periodic table, we know that each row is called a period. Each column is called a group or a family, and we can separate out our periodic table between main group elements and transition elements. With our periodic table, we know the difference between metals, nonmetals, and metalloids based on the staircase here. Okay, So let's talk a little bit more about our elements as well. Okay, so now that we have the basic structure of our periodic table, let's go through and talk about one other aspect, okay, before we get to compounds. And that is there are 7 diatomic molecular elements that you need to know. Okay, di means 2. So these molecules have 2 atoms in them. Okay, and they're molecules because when you find them in nature in their unreactive state, they consist of 2 atoms. They're not atomic, they're molecular. So most elements, if we keep breaking it down, you can break it down to the atom. Okay, and it'll still have the properties that we expect. So these are called atomic elements. And examples of those would be like gold, sodium, carbon. Okay, so we can get it down all the way down to a single atom. But what's more interesting, or what's also interesting, is that we have our molecular elements. We have some that are molecular, they form, like sulfur has S8, it has 8 sulfur atoms connected to each other. But these are the ones that I want you to memorize. Okay, okay. And that is going to be hydrogen. So it consists of 2 hydrogen atoms. Okay, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, so if you look at their formulas, they have 2 atoms of the same element. That's why they're elements, but they're molecular. Okay, consists of more than 1 atom. Okay, so there are several ways that people memorize them. Okay, they have these, what? I forgot what you call them, not anagrams. You can have Brinkelhoff, so bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. That allows people to remember the 7. Okay. Have no fear of ice cold beer. Okay. Hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. Okay, but please make sure you memorize these. All right, and now that I've introduced you and I've shown you some formulas, let's move on to compounds and formulas next.